Assalamualaikum and hi everyone. Today, me and my group would like to present a subtopic in mathematical computing, which is topic is differentation. The code is DBM10063 and our lecturer's name is Sir Hadi bin Hashim. So my group consists of 3 people, which is me, myself. My name is Nohana Ayuni binti Kamal Fuad. My matrix number is 01DDT21F 2069. Next, Nur Aini Fazana binti Muhammad Kuzari. Her matrix number is 01DDT21F 2010, and the last one is Muhammad Nur Azlan bin Rosli, and his matrix number is 01DDT21F 2063. This presentation, we will be using one digital tools and one mathematical application. The digital tool that we use is HeyHi. HeyHi is a lightweight whiteboard app which works on any device such as laptop, tablet, mobile device, optimal for Apple, Windows and Android operating system. Our service is designed specially for interactive real-time tutoring between tutors and students. For the application that we use is Photomat application. Photomat is an application that can be used by taking a picture of mathematical problem, and it will give several answer options to the user. It will display step-by-step explanation on the screen.
Thank you, Hannah. First topic is power of rule. If we are given a power function, fx equal x power of n or y equal x power of n, then we can find its derivative using the following shortcut rules, called the power rules. F prime x equal nx power of n minus 1, or dy over dx equal nx power of n minus 1. Example 1. If fx equal x power of 10, then f prime x equal 10x power of 10 minus 1. Then the answer will be 10x power of 9. So for this solution, I will be using Photomat. For the first step, take the derivative f open bracket x close bracket equal square root x. Second step, find the derivative f prime open bracket x close bracket equal d over dx open bracket square root x close bracket. Then the answer will be 1 over 2 square root x. So for this solution, I will be using AI. The question is f open bracket x close bracket equal 1 over x equal x power of minus 1, and f prime x equal negative x power of minus 2 equal negative 1 over x power of 2.
Thank you, Azlan. Now, I will present about the constant multiple rule for derivatives. So, you will need to know if we are given a function multiplied by a constant as follow y equal of a constant time the function of x, then we can find its derivative as follow y as derivative equal to the constant times the derivative of function. Essentially, we just move the constant multiple rule into the derivative.
So now I will be using solving steps in HeyHi. Such for example is fx equal 4x power 3, and then it will change it to fx equal 4 times 3 power 3, and then f prime x equal 4 times 3x power 2, and the answer will be f prime x equal 12x power of 2.
Next is the derivative of constant. The first rule you have to remember is the derivative of constant is 0. Fx equals c, so the answer will be f prime x equals 0. Such for example, fx equals 5, so the answer will be f prime x equals 0. So next is the derivative of an identity function. If given y equal ex, where e is a constant, then dy over dx equal a. Such for example, y equal 35x, then the answer will be dy over dx equal 35. Meanwhile, y equal minus x, then the answer will be dy over dx equal minus 1. And lastly, the sum rule. If we have a function given to us which is a sum of term, then we can find its derivative by taking the derivative of each of the terms individually. So for example, fx equal x power 2 minus 4x plus 6. The derivative of x power 2 is 2x, meanwhile the derivative of 4x is 4. And lastly, the derivative of 6 is 0. So the answer will be f prime x equal to x minus 4. This step, if you use Infotomat, take the derivative fx equal 5x power 7 plus 3x power 4 minus 2x plus 1. And then you use the differential rules, f prime x equal d over dx. And all the functions, differentiate it, f prime x equal d over dx. And the function in the bracket, simplify it, f prime x equal 5 multiply with 7 at x power 6 plus 3 multiply with fx power of 3 minus 2 plus 1 plus 0. And the solution that you can get is f prime x equal 35x power 6 plus 12x power 3 minus 2.
Thank you, Aini, for your explanation. So I will be presenting about what is composite function. Composite function is whereby y equal to k open bracket x plus b close the bracket power with n. So if we differentiate it, it will become dy over dx equal to k times with n open bracket ax plus b close the bracket, and the power n we must minus with 1. Then open bracket a close the bracket. So as you guys can see here, we have two brackets. For the first bracket, we just need to copy back the function, and for the second bracket, we need to differentiate the function of the first bracket. For an example, differentiate y equal to open bracket 5x power 6 plus 10 close the bracket power with 8 with respect to x. Step 1, recognize the composite function k open bracket ax. So the solution is open bracket 5x power 6 plus 10 close the bracket power with 8. Step 2, differentiate y with respect to x. So the solution is dy over dx. For the step 3, we need to differentiate composite function. K and open bracket copy back function in the bracket, close the bracket, and the power we must minus with 1. Next bracket, we must differentiate the function in the bracket. So the solution we get is 8 open bracket 5x power 6 plus 10 close the bracket power with 7 open bracket 30x power with 5 close the bracket. So for the step 4, we get the complete answer. We need to combine the dy over dx equal to 240x power with 5 open bracket 5x power 6 plus 10 close the bracket power 7. Okay, so this is the solving step that I use in Hey. So first, we get the equation y equal to power root x power 2 plus 4. Then we differentiate it, it becomes dy over dx equal to open bracket x power 2 plus 4, close the bracket 1 over 2. Then 1 over 2 open bracket x power 2 plus 4 close the bracket power with negative 1 over 2, and then open bracket 2x close the bracket. So the last answer we get is dy over dx equal to x over power x power 2 plus 4.
For the last, these are the questions we need to define differentiation as exercise for the class. Thank you for lending your ears and listening to our presentation. Thank you.